Okay, so I was thinking through like what kind of assignment could I do for you, and how could I kind of help you move a little bit further forward. And I was thinking, so we have like the multiply and the divide functions to do. So maybe, and I think those functions are pretty similar. Like those methods are pretty similar. So maybe if I walk you through how to do the multiply function, then you could do the divide function on your own. So I've started to write some stuff down for the multiply function. So I think that if I can explain this to you, and you can watch through and kind of understand the thought that I take on this, like the approach that I take, you can then apply that to your own. Because, yeah, I think that's just going to be the best way. I can show you a little bit first. All right, so going back into our code, I've written some basic stuff down here. Public fraction multiply, and I put that on the left side of the screen. Also, from our main class, we're still creating these two fractions, f1 and f2. New fractions, this is the numerator. First one's always going to be the numerator, the one on top. Oops. Numerator, denominator. So we have those two values for f1 and f2. And this is our multiply class, and we have two fractions. Well, we have kind of something coming in and something coming out. Coming in, we have a fraction that I just called to add, and then we're also going to be returning a fraction. Okay, and we might look like implementing this might look like this: system out print line f1 multiply f2. Okay, so what things do we have available to work with within this method? Well, because we're applying multiply, like because multiply is attached to f1's method, it's like we're using the multiply method from the f1 object. We have all of the stuff in f1 that we can access. We can access its numerator. We could do it by, I think we just access it directly using numerator, or we could use get num. I think we should have direct access to it within inside the method as well, but either one of these might work. We also have the access to the denominator using get denom. And I think, yeah, we should have direct access to both those values, or we could use the get num or get denom to get those values within. But it should be fine to just access num directly. But anyways, yeah, for sure. Also, the other thing we have available, we are passing into this multiply function, in this multiply method, we are passing an f2. So we have all of f2's data available as well to us. And since we're passing into the multiply method, this is going to go in place of the toAdd function. Excuse me, the toAdd fraction. f2, like same way we do with any method, we can pass in some data into the method. In this case, we're just passing in a fraction, and that fraction is f2. So again, we have access to all of its data. In this case, since we are passing this in, we're going to access its data. We'll have to access f2's data using get num and get denom. So anyways, we could maybe keep that consistent here. But anyways, our goal here really is to build a new fraction. We're going to build a fraction that I call temp. It's a pretty common like variable name for like temporary, where we're going to make something, we'll return it, and it's not going to exist anywhere except for inside of this method. And we could do a couple things first here, like if we want to build this temporary fraction, well, we said the first thing we have to do is we need to take the two denominators and multiply them together. So I'm going to make a new variable. I'm going to call it int. I'll call it like new numerator. And the int new numerator is going to be equal to, well, I need to get the denominator from fraction 1 and the denominator from fraction 2 and multiply them together. Well, since all this is happening inside of f1, I can access the numerator. Hopefully I said that right before, not denominator. I might get those switched up a little bit. I'm going to get my new numerator. I'm going to get this new num by accessing the numerator that I already have available from f1, and then I'm going to multiply it times toAdd dot get, and I think we'll make sure we get the names right here. We use get numerator. And maybe I could be a little bit clearer. This is a multiply sign, like that. So our new numerator is going to be equal to the numerator of f1 times getting the numerator from this fraction that we're inputting as a parameter to this function. Same thing here. We could do int new, and we'll call it denom. And we're going to get the denominator from our f1 function already. So I'm going to say denom. And I don't know if x or, well, maybe I'll do like that. And we're going to get our function that we're going to get to add, or like the fraction, the to add fraction. And we're going to get denom from that. So now we have a new numerator, we have a new denominator that's a result of multiplying these two things together. All we need to do is make this, as we make this new fraction, we need to take these values and put them into the arguments here to make our fraction. So we'll say fraction temp is equal to new fraction new numerator, new denominator, and then we'll return temp. Okay, so let's take a look at that. We can code that in here. So we'll say int new num is equal to, again, the num, we have access to this because we have access to any of F1's data. Any of that F1's data that's stored in here, we have access to it. We don't have access to F2's data because if we think about these two fractions, they're kind of like housed separately. So right now, if you want to think about it, like we are working within F1's class, so we have access to all of F1's data. But we're kind of pulling in F2, we have access to some of its data. We have access to any of the data that is public. So like F2, as we pull it into F1, kind of in a way, this private thing means that we can't access F2 stuff. We can only access the public things. So we can access these public methods from F2, but we can't access its actual data. We can't access its denom or its numerator directly. We need to use this get num thing. So that's the reason that here we can say num and know that it's referring to F1's numerator. We can't do the same for F2. We need to get its numerator by using this public openly available method. It's a little bit tricky because it's kind of like different classes, so it's something you need to practice with and kind of work with and mess around with to understand, I think, as best as you can. So, but this is going to work. So to add, and then we're going to get num. It's going to come get that, and then we can also do int new denom, and it's going to be the denominator inside here, and then we're going to take two adds, and we're going to get denom from that. And then the results of these two things, we're going to insert that into here. We'll get new numerator, new denom, and that should work. And we're going to return that value back to the user. So now if we go into our main class here, and let's, I know this is probably messing you guys up because you are, I can make a separate document here. But anyways, if we run this, everything looks good. I can even comment this part out. We don't really care about that. We just want to multiply these two together. We should get 3 over 8. So let's take a run at that. Pull this into here. And we get 3 over 8. It's working exactly the way that we think it should. Okay, so that is the end of the explanation for why multiply, how we can implement multiply. I'm going to talk about your assignment, and then also I'll talk to you a little bit about how we could simplify this, and maybe I'll talk a little bit more about classes, but I'll kind of include that at the end. You can watch it if you want, or not watch it if you don't want. Let's take a look through here. So basically your task is to implement the multiplication method, and I'll help you out a little bit here. Let's just get started with this one. It's going to be very similar to this. I said to add. I don't know why I said to add. I should have said to multiply. That's going to annoy me. I'm going to say to mult. Maybe it's late at night and my brain's not working that well. And because this one should probably be like to divide if you want, or to div or whatever. It might be a little bit quicker to write to div. So the same thing is going to happen here. We're going to take in a fraction that we want to divide, and we're going to return a new fraction back to the user. So it should work something like, if we go back to the main class, if we do divide on these two, just a little quick math reminder here, 3 over 4 divided by 1 over 2 is going to turn into 3 over 4 times, and we take the reciprocal, so we flip, and we can really flip, yeah, either one, then we get 6, 4. Can we flip either one? Yeah, should work. No, maybe not. No, we just got to flip the second one. So we'll have to flip the incoming one to get that. Yeah, I guess it doesn't matter because order is going to matter here. So 3 over 4 divided by 1/2, and we'll get 6 over 4. So that's what I want you to implement with your code. So if we take something like, yeah, so in this case, if I should be able to run F1 divide F2 and do system.print. And this should print out to me 3 over 4. Yeah, it should give me the result here of 1 over 2, and I should get 6 over 4 as a result. So this, yeah, with this coming in first, dividing by this, because order is going to matter here, we should get, oh, it's really messy over there. This is, yeah, 6 over 4. My brain is really not working. Yeah, 6 over 4 as a result of that. So you're going to implement that in your code using in the multiply function. I've written some things out for you. I'll include some of the starter code in the, I'll include this whole class in my email, reminder to myself, and also include this part. You're going to have to return some stuff. You're going to have to follow what we did up here to get a little bit further, to actually complete this. Okay, so that was the end of the instructional part as far as doing multiply and explaining this. I thought I wanted to do, I'll do a couple, I'm going to do two extra things. So if you are done, you feel like you have enough, that's fine. I'm going to show you 2 extra things here. One thing here, I was kind of looking into this, you know, I wrote this out to make it a little bit simpler to understand, because kind of we can break this down into small little parts, new numerator, new denominator. I could do that, get those values, get the next value, and then build the fraction from there, but I really don't need this value. Like, this isn't serving any purpose. So instead of doing, like, creating it here and then using it just one time later, I could also just put that right into here. And same way here, I could take the numerator and put it directly into here. I don't really care about having a new denom, so we delete all that stuff. And now we're creating the fraction directly based on our inputs. We'll create the fraction directly and return it. But at the same time, like, okay, I'm making a temporary fraction. Like, I don't really need to do that. I don't even know if this is really great. Probably the other way is better. It's not going to slow us down at all. It might be easier to read, but just kind of maybe just for your knowledge, we could take this, place it in here, and then our entire code is 1 line long. And now it's going to be, oh, it looks like we're cutting off a little bit. I mean, so we cut down significantly on space. It doesn't really matter. Maybe the other way is better, but I just want to kind of show you that even though we had all these steps, it's not really required. I mean, we could cut this down into just 1, and then I think if we run this, fingers crossed. Oh, because I have the to divide thing, I haven't done anything with that. It'll probably go through there and check as it compiles to see if everything's there. Yeah, so we get 3 over 8 regardless. We just kind of cut the thing down there. It's not like that big of a deal. I just thought it was kind of interesting to compare and contrast the 2 different ways of doing this, or 2 different level of complexity you could have here or not. You could really spell out every step, do it line by line, or do it kind of all at once. Not saying one's really better than the other. Okay, so in the last part of this video, and maybe be a little bit long, I hope to try and keep it short, but I think it's a really important idea and a way to kind of understand a few important topics here, like public, private, all this stuff here. And it's all this stuff. So I've just kind of copied and pasted in the class here. We have all the private variables we have up here. This is the constructor. We don't really need to worry too much about that for this. And actually, really, we don't need a lot of this stuff. These are all methods, though, so I'll leave those out there. What's key to note here is, like, we have a bunch of private stuff and we have a bunch of public stuff. The private stuff is all available only within this. Like, when we create a fraction object, the private stuff can only be called within that object. It can't be called somehow outside. If we want to get access to these private variables somehow, we need to use a method like getNum, which will return that num value back into the main class, or back to wherever else you want to use it. So I want to try and explain this a little bit and see kind of what we can do with it and why it makes sense that we can write this. And specifically, why we can write num here, but we need to write getNum here. Or why we can write denom here, but have to write getDenom here. Like, why does this work like that? Why do we have to go to mult get denominator here? And so let's take a look here. We'll try and understand as best we can. So the key point here is we need to think about, okay, we're running this multiply method. What object does that multiply method belong to? There's a multiply method that exists for any fraction, so technically f1 has a multiply method, f2 has a multiply method, but this specific one that we're calling right now, which one is it attached to? Well, it's attached to F1, right? It's our F1. We're attaching it from our F1 object, and we're running F1's multiply method. F2 has one. We just chose to use F1's. If we used F2's, it would just kind of flipped a little bit, but we could do that. We just chose to use F1's. So what this means is that we are, when we run this F1 multiply, we are kind of entering in my mind, I picture that we're kind of entering into the F1 object. We're entering into this kind of object, and it's got all these values. We have all like the personal data of F1. We have access kind of to its internal organs. We have access to its numerator. We have access to its denominator that we wouldn't have access to if we were outside of the object. But kind of running this method means we're kind of diving into F1. And as we dive into F1, we're taking along all the data that's attached to our F2 fraction object. So we're kind of pulling it in there. The data that we have available for our F2 fraction object is any of our public stuff. So we can do the public int get num, get denominator, we can do the toString, we can do any of that stuff, but we don't have access to the private information. Yeah, so when we get into, as we dive into F1, we do have access directly to its denominator or numerator. So that's why when we want to write this method, we can just say, okay, F1, let's get your numerator. We don't have to actually run this getNum because we're inside of F1. We have access to all of its private variables. So num in this case. However, we're passing in F2, and I'll do the little crossy hash thing here. We're passing in F2, but we don't have access to its private variables. We can only kind of see the outside, see what it's giving us outside, seeing the things that it's making public. So what we're going to need to do is we'll need to get this object's, like getNum, we'll use getNum to get its num. And so in this case we could say like, well, it's really, I don't know if it's confusing or not. I'll use F2 here just because it's directly here, but we'll say like F2 get num. And that's going to, as we dive into F1, we go back into F2 and say, hey, let me get your numerator. Let's get that numerator from you. And then we can multiply them together. Okay. I mean, the only difference here is that when we run this method, when we run the multiply method, we use the name, we didn't call the fraction F2 because it could be any F3, F4, AB, I don't know, it could be whatever fraction name you want. So we used a fraction name tumult. So we said, okay, F1, we have access to your numerator. We're going to multiply it by tumult's get numerator. So I think it's just kind of, I can see that would be hard to figure out kind of, I mean, it's very abstract. Coding is very abstract. So trying to figure out kind of what's going on here, why can we do some things but not others, is really important. And I think it's something that as you code and as you do the coding, you kind of, oh, okay, I kind of see how this makes sense. I can try and put the structure in front of you and show you how it kind of works, but until you actually do the coding, it really, I've probably said this a million times, but I'll continue to say it, it really doesn't make sense until you actually do the coding yourself. No way getting around that. Okay, so I think that's kind of where I'm going to leave off with this one. I just wanted to show basically why can we do this. I think the biggest question was like, why can we use num here, but we can't use num for like F2? And it's all about this public-private. What do we have access to? Because we're inside of F1, we have access to its private variables. Whereas for F2, we only have access to the things that's been made public for it. Okay, so that's going to be the entire thing. I hope that makes sense. I hope that adds a little bit of clarity. Shoot me back any kind of questions you might have, and I'll see you later.